Hello everyone, good day. I haven't seen you since Friday, so I hope everyone had a nice weekend. And I hope that there was at least some opportunity to relax on Monday. Any questions from you guys before we get started today? About anything at all? Yes?
If we finish like the virtual lab like early, can we turn it in early? Or
Absolutely.
Okay.
I will never not accept anything early. I will also accept things late. So you can turn it in functionally whenever. But the lab is specifically supposed to be due by the end of next Monday, the 13th, which actually is also when the homework is due. So I will go ahead. So that just real quick. Homework and quiz and lab due by the end of Monday. Any other questions about anything at all? Okay. So, I have been getting several questions about the homework over the weekend and via email, which is a good thing, to me at least, because as a person who is a physicist and has been doing these same questions as a teacher for years, sometimes I forget which ones are hard. And honestly, different groups of students will find different ones hard. And hearing from you guys of what things are causing you trouble helps me to know what I need to focus on with you guys. So thank you all for the questions that you have been sending in. And to help everyone continue to get started with the homework and to get through some of these questions, my main focus today is just going to be looking at the homework with you guys and working through a lot of the issues that people have been reporting in. Hopefully I won't forget how to talk too often today. At the very least, because they're questions I've been commonly getting and they contain things that I want to make sure that I cover with you guys, I've already set aside some time for numbers 1, 2, 6, and 7 on this particular assignment. Is there anything already, like any other numbers on the assignment off the top of your head that you guys know that you definitely want to spend some time looking at today in addition to these? And it's okay if you don't have that answer right this second. Yes?
Number 10.
10. Take a second for you guys to find them. It's okay if we can add on to this list later as well.
Number 5.
5. Okay. So, let's go ahead and get started. We'll just go down them in order, and again, any other questions that come up, please ask them. This is not going to be all we look at. And let's see how I can help you guys with this particular assignment. I do, again, in general, welcome all homework questions, not just this assignment, but all assignments. I am always prepared to pull up WebAssign and look at them with you in lecture, which is why I tend to make the homework due after a lecture, like on a lecture day, but at midnight. And this, like the numbers that are currently on screen, a lot of them will be different to the ones that you are working with. Just for the unaware, WebAssign will randomize all of the red numbers so everyone is working with something slightly different. This is actually to encourage you guys to work together, but specifically to encourage you to work on how to find the answer so that you can help each other with that method and not just copying the number down. Now, some of them actually don't have any red text in them because they tend to be about formulas or about universal constants. We'll look at a few of those together today. I want to quickly look at 1 and 2. 1, I think, has been causing some problems just because of the strangeness of a firkin, which is completely valid. So we'll look at that quickly. We are told, well, within number 1, we are given a fixed number of firkins. Everyone's exact red text number will differ somewhat, But I recommend when it comes to the conversion, starting with that number you are given, the unique beginning value, because that number is not actually itself part of a conversion factor. It's not part of an equality, which means it begins as its own non-fraction number. You can't introduce this as a part of the conversion chain because it's not a part of a fraction. This is the beginning of the railroad network, and it will end, ideally, the way that I set them up. The system will end on the final answer, which is also not a fraction or an equality. So start with number given. From there, the conversion for, I'm just shortening firkins to F. The conversion we're given for firkins is 1 firkin to every 9 gallons. So we multiply by 9 gallons over 1 firkin, which is ultimately just multiplying by 1, because these two things are the same as each other. This will cancel out firkins. So ultimately, just the number you're given times 9 will be the number of gallons that you've been given. However, we do want our answer in terms of meters cubed, which means that there does need to be at least one more step. And on homeworks and labs, I consider the internet to be an open resource, and this includes looking up any and all conversions that the assignment fails to mention, because these questions are from a textbook that would have most of these conversions inside the cover. So Googling these is fair, emailing me about them is fair. Just for a frame of reference, when we're doing a test together, I will personally make sure you have all of the constants either in the question or I will put them on the board. For this specific case, you could convert from gallons to liters and then from liters to meters cubed. I prefer as few steps as possible, so I looked up straight from gallons to meters cubed. So I am using this conversion. You are welcome to use a slightly different chain of events though, as long as it makes logical sense. And so orienting it like this, such that we cancel out gallons and are left with meters cubed on the top, that should arrive us with one final whole non-fraction number at the end, 4 meters cubed. And again, this part will vary, but these steps should get everyone there. And while we are, I'm going to leave that conversion up for a second, but while we're here at the beginning, before I have to scroll away, I want to briefly look at number 2, because I've gotten a couple of questions about how WebAssign handles scientific notation, which is fair because, again, I'm going to reference this a lot today and until probably the heat death of the universe. WebAssign is not smart. Robots are dumb. I don't care how smart technology is. I don't care if we call it artificial intelligence or not. At this point in human history, machines can only do what they're coded to do, which isn't much. So this particular platform we're using does have a tendency to misinterpret answers, so often I'm going to be trying to tell you how to minimize its confusion, or I'm going to be telling you, email me and I will fix your points from the other side, from the teacher end of the portal. For number 2 specifically, you are converting speed of light into miles per hour. Something that fast is going to be a big number, pretty much regardless of the units you're using. And so when you do the conversion, you will get a very large number, upwards of about 670 million miles per hour, which is a big number, and there's 2 approaches you can go about for inputting it into WebAssign. One is just to put in the whole long string of numbers that your calculator gives you, and WebAssign should count that as correct, because at the very least, it's a calculator, so it can convert between your answer and the scientific notation form it's expecting. It can do that much. So the big long number that you're given, you can put that there and that should still work. But some calculators give you scientific notation as an answer, and some people prefer scientific notation as an answer. So to explain the blurry digits that are currently on screen, WebAssign is expecting 6.71 E to the positive 8. And math and science tragically ran out of Latin letters a long time ago, which is why we started robbing symbols from the Greek alphabet. And in my opinion, we need to continue robbing more of them from probably the Cyrillic alphabet, because we're still reusing Latin numbers for some reason, Latin letters. In math, lowercase e is commonly the natural log e, which is not what it means here. There's just an unfortunate inconsistency where that lowercase e keeps popping up, much to my irritation. I tend to write this, and my calculator tends to write this, as a small uppercase e to avoid that confusion. So if your calculator says something like this, it means the same thing. Just, again, we ran out of letters a long time ago. So either way this e is written, it's shorthand for times 10 to the blank power. And you fill in the blank with whatever number comes immediately after the e. So the answer given here in WebAssign is 6.71 times 10 to the positive 8th power, which is the answer 670-ish million. So putting it in this form, WebAssign, again, should be able to interpret the answer correctly. If for some reason it doesn't, please tell me. I will get you your points. I'm not going to let the machine ruin you guys' grade. Yes?
I have a question about number 1. I
Okay.
did it a little bit differently. So instead of just go from gallons to meters per cubic, I tried to converting that go from the F to meters per cubic directly. But it ended up giving me the weird answer. It didn't match.
Okay. Well, did you look up a conversion from firkins to meters cubed?
Mm-hmm.
Okay.
I didn't really like.
Nancy, look. Huh. Well, let's see. Number doesn't seem far off from mine.
I plugged that number twice into it and it counted wrong.
Okay, so let's just look up firkins to meter cubed. Yeah, that's the conversion I get Googling it. Let's input my number, 8.18. See if it gives me what WebAssign wants. It does not. What? Okay. Time to perform math, because maybe WebAssign is wrong. That happens. There's been times where WebAssign's internal calculator is just wrong. So please let me know when you suspect that might be the case. Okay, so me with my calculator doing this gets me to what WebAssign is expecting. So I'm wondering if the conversion you found online just doesn't work for what WebAssign is using. And I'm not entirely certain, because again, who uses a firkin? I'm actually going to look at this conversion real quick. 9 times 0.00378. Yeah, I think the conversion you got is off, which, again, I don't know if it's adequately representing a firkin or not. So let me know. If you could send me an email about this one, I will make sure to get you your points back, because I'm not going to penalize you for the internet being wrong. So send me an email about that one.
I did send you.
You did?
Yes, sir. And I sent a picture of the work as well.
You did, yes you did. Did I respond to that? Okay. Pardon me, everybody. I'm going to check my inbox again and make sure I have that one starred to look back at. I apologize.
No problem.
I didn't realize that that was the issue. Oh, I see the problem. I opened it and started typing, and then I didn't hit send. That one's entirely on me. My mistake. I'm going to reseal it and star that. And make a note of it in my file. Okay. Any other issues with number 1? Or 2, while we're still here? Okay. We've got a question about 5, which I think is the fountain trig question. Yes. So, number 5 is a trig problem, and thankfully it gives us a nice partially formed triangle to set up from. Everyone's number will differ slightly, but we are given the circumference of this water fountain, which this particular person found by walking around it. So there's really 2 pictures here. One is our fledgling triangle, which I have not drawn to scale. And one is the circumference of the water fountain. Now, everyone is given the same 55 degrees. What we ultimately want is height of the water. We know one angle, we want one side. We need one of the other 2 sides to figure that out. We are given no information about the hypotenuse, but we can work backwards from circumference to find circle radius, which would be the x leg of the triangle. And as a refresher, which and I needed to look this formula up myself because I can't remember them half the time. Circumference of a circle is equal to pi times 2r. So whatever your circumference is, you work backwards to find your radius. Radius then lives here, and I would recommend consulting tangent to find water height. Any questions or needs about 5 for right now? We can come back to it if we need to. Okay. Now, I really wanted to get to 6 because it's a bit of a doozy. Now, a couple of fun facts about WebAssign. Again, because its AI has a hard time interpreting answers, it can't actually interpret pictures and diagrams that you upload at all. So if for some reason a question asks you, please upload a file of blank, any file will work. It gives you a point as long as file is uploaded. So it doesn't have to be a diagram of this. It could just be a 1 pixel PNG and you get the point. It is incapable of actually interpreting the answer. However, what you should actually do at this step is draw out, for your own benefit while working the problem, a picture showing what's happening. And I will go over this particular image myself in a second. I got a previous attempt already drawn onto the board. I want to talk about this question in particular because it involves a situation that I have come to refer to as 2 equations and 2 unknowns. And I'm going to step you through all of that algebra because this type of thing will come up from time to time if you haven't already used it before now. The physical situation presented in this question is we have a mountaineer, a hikeist of some description, and she is standing some unknown distance from a mountain of unknown height. So we don't know this leg of the triangle, and we don't know this leg of the triangle. What we do know is she's able to measure the angle between the ground and the hypothetical hypotenuse formed between the triangle of the ground and the mountain height all the way back to her position. She walks some distance forwards. Everyone's exact number will vary, but we do know how far she walks. And then at this new point she finds herself as, she repeats her process and finds that after having walked blank distance, that angle has now changed to 14 degrees. We still don't know how close she is to the mountain. The only distance we have is the distance between these 2 points. And now I'm going to teach you how to use that to figure out mountain height. And this is an actual trick you can use if you are able to hike 5 kilometers closer to a mountain and if you can gauge the angle in question at 2 positions. I believe this is something that historically was done to estimate mountain heights before we could actually measure them directly. The one picture presented here is really 2 triangles lapped over top of each other, which I've separated over here. First triangle has the 12 degrees. We don't know the distance between starting point and the mountain. We don't know mountain height. All we have is the 12 degrees and the right angle, which gives us enough to find all 3 angles, but that doesn't tell us anything about the sides. Second picture is the 14-degree picture. It's the same mountain height because the mountain didn't change. What has changed is the X leg. We still don't know what it is, but we know it's at least shortened by whatever distance was hiked. So we still don't know either one of them, but we do still know how this one changed relative to the first one. Now, WebAssign itself does ask you to then, from these triangles, consult tangent and write some functions in terms of the tangents of each of these angles. And so I have done the same. From triangle 1, tangent of 12 is opposite, so our y leg over adjacent, which is going to be our x piece. Do the same thing to the other triangle, and we'll get tangent of 14 equals h over x minus distance hiked. Now, looking at either of these by themselves, we can't solve for height yet. When you are doing algebra and you want to find a number from your formula, you want your one equation to only have one unknown thing in it, so you can perform algebra and end up at variable equals number. But if there's 2 unknown variables, you can't do that with one function. However, one equation, one unknown works, and 2 equations, 2 unknowns work. As long as you have 2 functions with the same 2 unknowns in them, you can jury-rig your way to an answer. We're going to do that by basically removing x by setting everything equal to x. From our tangent functions, I recommend moving x to the left side. Here, that on the 12 degrees, that's pretty straightforward. We'll get x equals h over tan 12. There's a little more work involved on the second one, but it's not too much. We have to take the denominator, send it to the left. We can still bring the tan 14 to the denominator on the right. We will ultimately end up with x equals h over tan 14, all of that plus distance hiked. And now we have 2 functions of x equals blank. Any questions, concerns getting to this point? Okay. Now that our 2 equations are in the form of x equals blank, we know that this equals x, and x also equals this. So we can set them equal to each other and make x not exist anymore, thus reducing us, once we combine them, to one variable, one unknown, one equation. And again, does anyone have any questions or issues with getting to here and then from here to here? Okay? Once we're here, there's only one unknown left, the h that we want, and this is why I recommend doing it this way, because if we had solved for both h's here, we would have eliminated h and then found x, which we would then have to take back into the original formula. So doing it this way saves us at least a few steps, weirdly. We now have just the h remaining. I want to get all the h's on one side. We can subtract this term over. I've kind of skipped a few steps here, I apologize. Subtract this step over and distribute the h out of those two pieces. Does anyone need me to show the step in between? Okay. And once you get here, this whole thing, 1 over tan 12 minus 1 over tan 14, is a number. You can find that number, it's just some fraction, and then you divide it over underneath whatever number your hiking was, and you'll get your final numerical answer. Everyone's will be slightly different, but the number should be more, just so that you know when you get the answer, just so that you have some sense of scale. Your final answer should be bigger than the distance hiked. If you get an answer smaller, then that's your cue. Something didn't work right, reconsult math. Yes?
So the answer that we get is basically the whole length, basically,
No.
or just x.
We're solving for h.
Mm-hmm.
So that should just be
Oh.
mountain height.
Mm-hmm.
We could solve for x, and if we found x, it would be this whole length, as we indicated here. X is the base of the 12-degree triangle. The 14-degree triangle would be x minus 9, so it would be smaller. But we did it this way, so we get h, and h is the final answer, the height of the mountain. Issues, questions, comments, haikus, etc. Okay. I'm out of water. It's noon, so we'll take a quick break while I refill this and rest my vocal cords. We will continue consulting a few more. And again, if there's questions other than just these ones, please let me know. We will talk about them, and we'll reconvene in a second. Yes.
So with this answer, when you find y, are you taking that bottom part, the h, and
Oh.
the parentheses at the bottom and setting it equal to your kilometers?
Sorry, say that again?
Like, how are you finding y?
Okay. I don't know why I did this. H is y. I don't know why I used H instead of y. It says y over there. But this final answer, like if you solve for H is y, H is the answer to C.
Using the h parentheses 1 over tangent?
Yes.
Because when I do it, I'm getting a number that's like point something. Like point.
May I look at your work? And
four-
is your calculator in degrees mode?
That's a good question. I don't even remember how to figure that out.
That's fair. It doesn't come up until it's suddenly important.
Yeah, I have the old one. I don't
mode. It is in degrees mode, but just so that you know, mode degrees is the one highlighted, so that's not the issue. And if you
Unless I
were,
just did my math wrong.
you're allowed. And the number given was 3.04. Okay. May I borrow this real quick? Just check my homework.
Okay, I think I did it, I got like 4.38.
Yeah, that's what I'm getting right
Okay,
now.
but I just did my math wrong. I think I just plugged something in weird.
I myself, working it just now, did a plus instead of a minus, and that definitely screwed something
Thank
up.
you.
All right. Any needs, concerns before we resume? Okay. Pulling this down so that I don't have to erase my work. Number 7. I definitely want to look at this one because the definition of constant speed is actually something that I haven't mentioned quite yet. So if you've lost points because of that fact, please let me know. I will address that. The definition of, average speed, or possibly average velocity, is total distance divided by total time. Say you are driving to grandma's house that's 500 miles away, and that takes you 8 hours. You could divide 500 by 8 and find average miles per hour, but that is not the speed you are going the entire time, because you're going to stop, you're going to speed back up, the speed limits are going to change, you're going to get caught in traffic. So average speed represents an average of everything factored into each other, but sadly you can't get there by just taking all of the velocities listed and averaging them, because that doesn't take into account how long you are moving at each of those speeds. So instead, the formula we use for average speed is total displacement over total time. And in this particular case, this driver is realistically moving at different speeds for different lengths of time. We need to find the displacement for each of those legs of the journey, and then also the time that it took for each leg of that journey, and add all the distances together, add all the times together, and divide the total distance by the total time. And I recommend doing it this way because part B's answer is the total distance, so you will need this number by itself, or your equivalent to this number, because every single red number is different for you guys, so keep that in mind, keep the structure of this. The way that I've laid this out with my numbers is, let's just look at the first leg of the trip. 60 kilometers per hour, for 55 minutes. So to find the distance for that leg of the trip, take the velocity, multiply it by time. However, we were given minutes instead of hours, so I've done a quick spot conversion back into hours first. So 60 times 55 over 60, that will give us just less than an hour, so 55 miles actually. And that'll be the distance driven for that leg. Meanwhile, it took 55 minutes to do that, which is back into hours would be 55 over 60 hours. second leg of the trip was 70 kilometers per hour for 11 minutes. So 70 times 11 over 60. And then down here we have the hours equivalent of 11 minutes. Next leg, 35 kilometers per hour for 30 minutes. And then the last leg, stopping and buying gas and eating lunch, we are going to assume driver safety and that there was no distance traveled during that time. So distance chunk there is a 0, but time still passed. So we still need to factor the time in. Add all these distances together, you'll arrive at the answer to part B. Make sure to add all the times together, divide them accordingly, and you'll get kilometers per hour average for the entire journey. This type of question shows up again. I'm going to skip ahead just briefly for number 12. Number 12, you are similarly given different legs of a journey. You have to find the displacement of that leg and ultimately divide it by the time for that leg. So again, keep this definition in your notes. Probably put a big box around it. Any questions about 7? Yes.
You go right as well, please.
8. Yes. You can look at 8. I will do 8 before 10, just because that's the order we're going to pass them in. But we will definitely still do 10. Number 8. Graph of position versus time for a certain particle moving along the x-axis is shown in the figure below. Find average velocity for the time intervals. So, to address something about this graph, position on the x-axis is on the y-axis of this graph. This is a x position versus time graph. So this is going to represent scaling back and forth along the x-axis as time ticks forward. So counterintuitively, x coordinate does not mean x location of the particle being studied. That is worth keeping in mind. We are still given a very nice graph, particles moving along the axis over time, and we want to find average velocity for specific time intervals here. So, part A, I believe everyone will have the same graph and the same numbers, so we can, working this one out together, there won't be any variance. First time interval, 0 to 2 seconds. So we're going to look at our graph, which is really, really small and blurry on the board right now. I apologize. But from 0 to 2 seconds, time is on the x-axis. Our particle scaled from 0x to 10x. So average velocity for that would be displacement of 10 divided by time of 2, 5 meters per second. Next is 0 to 4 seconds. So over that 4 seconds, the particle, at the end of 4 seconds, the particle ends up at 5 meters. It did get there by going forwards and then turning around, but average velocity just cares about total distance over total time. So that's going to be 5 meters divided by 4 seconds, 1.25 meters per second. Next part, slightly trickier, 2 seconds to 4 seconds. So here we start looking at the 2 mark and then look at how far it went to get to the 4 mark. So this is going to be over a period of only 2 seconds instead of only 2 seconds elapsed here instead of a full 4 seconds. And in that time, the particle went from 10 meters to 5 meters. So the displacement is actually -5. Because we went from 10 to 5, that's going to be 5 minus 10, -5. So -5 over 2 gives us negative 2.5. Any issues proceeding from there? Okay. D is another piece of the question from 4 to 7. And then E is the whole trip, actually. E is pretty straightforward. The whole thing took 8 seconds. We started at 0. We ended at 0. Even though it's zipping all over the place at high speed, the average for the whole 8-second trial is still 0. This might be completely out of nowhere, but has anyone here ever watched a show that featured The Flash or read a Flash comic? Because he can do a trick pretty similar to this, where instead of running around at top speed, he just vibrates in place at top speed. So his average velocity would actually be 0, yet his particles are moving back and forth at a speed such that he can phase through solid matter. Similar weird quirk of math. Any issues with 8? Yes.
Could you, like D, could you just walk through D? Because for some reason I'm getting the wrong decimal.
Sure. I admit, on the board, everything's kind of fuzzy. I apologize. D, we're looking at 4 seconds to 7 seconds. So that's going to be over a span of 3 seconds. At 4, we're starting at 5. At the 7-second mark, we're at a position of, I hope that's negative 6. I believe that's the intention. So we go from 5 to negative 6 in 3 seconds. Unless it's...
I think the reason it was wrong is because it should be negative 5.
Okay.
I think when I looked at it, it just looked like 6, so I said 6.
I would assume that too, looking at how blurry it is on screen. I'm going to check on my other monitor real quick. Okay, yeah, so it wants negative 3.33. Yeah, that would be a distance of negative 10. So going from 5, yeah, I think the graph is trying to show going from positive 5 to negative 5. And the picture's not good at that, so I apologize. Yeah, I think that final distance is supposed to be 5 in the negative x-axis, so it would be 5 to negative 5. So, sorry about that one. Please, yeah. I don't want that, that's a bad picture. I don't want that stealing anyone's points. So if you had any issues there, please, if you send me an email, I can check your scores specifically. We're nearing the end, so let's look quickly at number 10, which might involve a similar graph. Actually, not quite the same kind of graph. We have a velocity versus time graph for an object moving in a straight path. So instead of showing us where something is, this is just how fast it's going at any given moment in time. And we're asked for the average acceleration of an object during certain time intervals, and then the instantaneous acceleration at different time intervals. Okay, I'm glad someone asked. There is a difference in the definitions there. For part I, for the 3 bits of part I, average acceleration is found the same way as average velocity. We want to know, I guess, average change in velocity for the entire time period over the entire time period. So actually that's just the normal way of finding acceleration. So A through C is the straightforward part, but there is a bit of averaging involved. Part A, 0 seconds to 5 seconds. So from 0 to 5, the object's velocity is consistently -8 meters per second. it doesn't change in that amount of time. So -8 minus -8 is going to be 0 change over the 5 seconds. So we result in 0 acceleration for that moment, for that interval of time. Next, we're looking at 5 seconds to 15 seconds. Here, from here to here, our velocity changes from -8 to +8 over a period of 10 seconds. So +8 minus -8 is going to be +16 over 10 seconds as an acceleration of 1.6. And then the last piece, it's asking about the average for the entire thing, 0 seconds to 20 seconds. Yes, at time equals 0, we're at -8. Time equals 20, we're at +8. So that's still going to be 8 minus -8, but now over 20 seconds instead of over 10 seconds. So, again, using the averages method, this is how we arrive at these answers. However, this is not an accurate representation of the exact acceleration during these moments. So we do have a different way of looking at acceleration, and that's instantaneous acceleration. Rather than looking at data and calculating an average after the fact, this would be what your car would say if it had a built-in accelerometer. In the exact moment where you are recording this data, what is the acceleration at that precise second? And the best way to determine that when you have a graph is to look at the time in question and find the slope of the line there. Because on a velocity versus time graph, since acceleration is change in velocity with time, on a velocity versus time graph, acceleration is the slope. Similar to how on a distance versus time graph, velocity would be the slope. As you change graph types, you change your relationship with time. So, looking at the graph we have here, instantaneous acceleration at 2 seconds. At time of 2 seconds, what's the slope?
0.
It's 0. It's a flat line, so there's no accelerating. We're still moving at constant velocity. Next, at 10 seconds, the slope coincidentally is going to still be 1.16. But then, at 18 seconds, the slope is leveled back out to 0. And so we have all of these different measurement types and definitions because sometimes different pieces of information are useful, and sometimes certain pieces of information don't tell us anything of value. Any questions, issues, etc. with this one? Okay. Your assignment is to keep working on your assignments, both the homework and the lab. The quiz also exists, but again, I recommend you do that after you do the homework in its entirety. I will see you guys again on Friday, where we will A, continue looking at any issue questions that you have, and B, probably continue examining or starting to examine two-dimensional and projectile motion. And until then, have a wonderful day.